Okay, here we go. So you have this question. Anybody know what what does this mean? What is it asking you for? It's telling you if the function equals that. What does this mean right here? The nth derivative. Right, exactly. So if you take the first derivative, so the first derivative, what's it going to be? What's going to get popped down to the front? N, and then it's going to be e to the. It's going to be what? Oh wait, do you just drop the n to the front? Can you do that?
Yeah.
Yeah, you sure? Yeah, sure. Why not? It's the chain rule, right? So it's just e to the n x, right? Because like what if what guys, if j of x was equal to, I don't know, e to the 3x, what does j prime? No, I'm writing this wrong. What does j prime of x equal? 3e to the 3x. So if it's y equals e to the nx, what's the first derivative? N times e to the nx. So then what's the second derivative going to be? What's the second derivative going to be? What happens? You have to be really careful. Well, hold on. This is important. This is kind of ambiguous, but is n a variable or a constant? It's a constant, so you don't have to use you do not have to use the product rule here. Things will get really nasty if you had to use the product rule all of a sudden. Do you have to? No. So what do you drop to the front? So it's going to be n what? N squared e to the nx. So what do you think y to the n is going to be? The nth derivative. N to the n e to the nx. So which one is that? A, right there. The exclamation point means factorial. N factorial means n times n minus 1 times n minus 2 all the way to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. Does that make sense? Look what it wants you to do. It wants you to, instead of doing f of x minus 3, it wants you to do f of x. So what kind of integration, what method could we use right now? If we wanted to rewrite this, how could we rewrite it? What method would we use? If we want to evaluate an integral and we want to simplify what's inside the function, what method do we have? Use substitution. So let's just say right now, let's just do this here. Let's say u is equal to x minus c. Is that correct? You see what I'm saying here? So I'm just going to rewrite this in terms of u. I'm not going to do du or dx. I'm just going to rewrite this. So what does this become? If I take this right here and I plug it into here, you get the integral of f of what? F of u. That's correct, du. Yep. From what to what? X minus c. So it's going to be 1 minus c and what? 2 minus c. So if we know that this thing is equal to 5, what does this thing have to equal? It also has to equal, but here's the thing. What's the only difference between this and this? X and u. Does changing the name of the variable change the overall value of the integral? No. So by this logic, what do we think the answer is? We think it's B. Let's check. You're taking the derivative of the sine inverse of 2x. So first of all, do you remember this? What's d dx of sine inverse of x? 1 over what? Square root of what? Are we sure of that? How sure are we of that? We're pretty sure. Okay, so if that's the case, we can do the same thing, but instead of x, what are we plugging in? We're plugging 2x in. But if you plug 2x in, what's the invisible thing that's right here? The chain rule. You have to always remember that the chain rule is present, so in this case it's just 1, right? But if we're plugging in a 2x, what are we going to have to plug into the outside? The 2, exactly. So if we do this, so we know therefore that d dx of sine inverse of 2x, which is what it's asking, it's going to be 1 over the square root of 1 minus 2x squared times what? Times 2. So you end up with 2 over 1 minus the square root of 4x squared. Is that one of them's listed? Which one is it? It's not B. D. It's D. Okay, so you're integrating. What do you think you need to use? Yeah, let's use u substitution. So we said u is equal to what? Oh, 1 minus x squared. So du is equal to 2x dx. So dx is equal to du over negative 2x. So now what do we have? The integral of 2x over the square root of u times, instead of dx we have du over. Does the magical thing happen that we hope happens? Yep. So what do you end up with? Negative the integral of u to the negative 1/2 du. But what haven't we written in yet? The what? The limits of integration, right. We haven't written in the limits of integration. We know that u is equal to 1 minus x squared. Plug in 0, what do you get? 1. Plug in 1/2, what do you get? 3/4. Now, what's the one thing that kind of bugs us about that integral if it goes from 1 to 3/4? It's bigger to smaller, so if we want to, what could we do? We could flip it and change the sign. So yeah, you can end up with 3/4 to 1 of u to the negative 1/2 du. Now, is that something that you can integrate? Yeah. So what do you end up with? What do you end up with? 2u to the 1/2 from 3/4 to, is that correct? So 2 minus 2 times 3/4 to the what? To the what? 1/2. Is that vaguely correct? I think it's correct. What do we think? 2 times the square root of 3 over what? 2. So you end up with 2 minus. Is that one of the answers? Yay! So it says if f of x plus 1 plus f of x plus 2 is equal to f of x plus 1 plus 2, for all real numbers, blah, 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 which of the following could define f? How would you go about doing this question? What could you do? Guess and check, right? You could just come up with specific examples, and maybe one of them will work and all the other ones won't. So, for example, you could pick f of can x1 equal x2 in this case? Could x1 equal x2? Absolutely. So you could try that with some trivial case. You could just try x1 is, f of x1 is 0 and x2 is 0. You do this one by trial and error. This one's a little challenging because you can choose any numbers you want to test. So choose x1 equals x2 equals 0, then x1 equals x2 equals 1. Now, if you had started with x1, if you started with this one, would you get the answer right away? Sure. Are you always going to start with the best pair? No. I chose 0 because why did I choose 0 and 0? They're really easy to plug into functions. Just take the derivative and see what happens. So, for example, on this, let's try it out here. On this one right here, if we do this one, the derivative is going to be negative 2 times what? 1 over cosine 2x times the derivative of cosine. Derivative of cosine is what? Negative sine of times what? So what do we end up with? Yeah, there's a problem here already. What do you end up with out front? Negative 4. So does this one work? No, it does not. So what does that tell us? What do we think should be out front? So we're really down to these right here. Okay, so we know if it's negative 1/2, because we're going to pop out a negative sign, we need it to be positive. So we think it should be negative. So which one do we think it should be? B. How do we test it? We just take the derivative. Either with negative 1/2, 1 over cosine of 2x times sine of, negative sine of 2x times what? 2. What cancels? And the negatives cancel, leaving you with just sine of 2x over cosine of 2x, which is tangent of 2x. Does that make you happy? Yeah. Velocity function that looks like this. And let's say you wanted the average velocity from here to there. So you want time equals a to time equals b. How do you go about finding the average velocity from time equals a to time equals b? What do you find first? You find the area under the curve, and then you divide by b minus a. You find the area, so if this is f of x right here, you do the integral from a to b of f of x, and then what do you divide it by? B minus a. You divide by the width. So when we were doing test scores, you have the first test score, the second test score, the third test score, the fourth test score, the fifth, sixth, seventh, eighth. You added them all together. The act of adding up all those test scores together is functionally equivalent to finding the area under the curve. And then you divide it by the number of students. The number of students is functionally equivalent to the width. So on this question right here, it gives you a function. And it says, find the average value of that function on the closed interval 0 to 2. So what's the width in this case? 2. What are you integrating from and to? 0 to of x squared times the square root of plus 1. And then what are you dividing by? 2. You're dividing by 2. It's the same thing as dividing by 1, multiplying by 1 over 2 minus 0. Is that something you can integrate? It is. Do that now. This can be. Yeah. So du is equal to. So dx is equal to du over 3x squared. So you have the integral from what to what? 1 to what? 1 to 9, yeah, exactly. X squared times the square root of u times du over 3x squared. You have a 1/2 out here. Does something magically cancel? Yeah. What are you left with? 1/6, the integral from 1 to 9 of the square root of u du. That's kind of nice. Am I okay so far? How am I doing? We're good? So what do you have? U to the what power? I think it's 3/2, right? It's 1/6, and you're going from 1 to 9. So what do you end up with? 1/9 u to the 3/2 from 1 to 9 equal to 1/9 times 3 cubed minus what? 1. So you end up with 26 over 9.